Skal vi starte? Der, ja. Okay. Guess it's time. I'm Tore Vesthus. I work for Beck Consulting. I'm a consultant, and I am a developer. Today, I'm going to talk about one of my favorite topics, which is a style of programming, or rather, my style of programming. It would have been stupid of me to try to talk about a style of programming that I would find very good and interesting and not adopt it myself. So today I'm going to talk about the way I develop software and the way, and this is a style of programming that has been evolved ever since I started developing software, which I did say I've been developing software for 10 years professionally, and then before that I developed software too in smaller scale. But this is a style that has evolved, and this has become my style of programming, and I want to share it with you. I'm going to describe the values and principles that colors every decision I make when programming. Either you're aware of it or not, we all have a set of values when we program, and these values colors all the decisions we make. I like to make those values explicit, and when I make those values explicit for myself, I become more aware of how and why I develop the way I do. I'm not only going to talk about the values, but I'm also going to talk about how it relates to actual code. I read too many articles and I see too many presentations where we hear all the buzzwords, but we don't really know how and when to apply these principles that we hear about. So I'm going to give examples of decisions that I make based on these fundamental values that I have. I'm also going to say that the driving forces of the way I develop software is ISO coding, ISO changing, and ISO testing. The point is, it should be easy to develop software. I've had too many painful moments, been sitting on too many painful code bases and too many painful projects to know that that's not the way to do it. I've been more and more aware of this is not how I want to develop software. I want it to be easy, simple, and clean. I'm also going to say that we all do object-oriented programming, right? But I think I've been very influenced by both object-oriented and agile developers, which often is the same thing. And I think I've tried to be very explicit on the object-oriented part in my development. And I think it really works for me. And before I start, I also have to say that this is not the style of programming. There are no the style of programming. The point is that the style of programming that you have really depends on the values that you have that are the foundation. So this is just one style of programming, and it's mine. Okay, let's start here. Object-oriented software, and let's start here. I think we should reflect a bit on what we're really doing as developers. Let's start all the way from the start. And we probably all know what we're doing, but I think it's important to be explicit about this too. Douglas Crockford said this, or wrote this. He said that computer programs are the most complex things humans make. When I read this the first time, I thought, there are a lot of complex things in the world, and we make a lot of complex things. But when you start to think about it, what we do is creating software programs that are made up of a huge number of parts. And they contain extremely detailed instructions. Extremely detailed instructions. We say, if this, if that, then do this, then do that. And we don't think about these as extremely detailed, but they are. They are expressed as statements. They are on different levels of abstractions. We have to go up and down, understanding these abstractions. They're arranged in sequences. It matters. The sequence matters. And all this has to be virtually free of error. When you see it this way, he might be right. What we are doing is actually one of the most complex things you can do. And then my question is, how do we handle that? And many will probably say we don't. But at least how do we try to handle this? We apply structure. What we as developers are basically doing is we're trying to structure enormous code bases. Enormous is a relatively term here, but we manage a huge pile of code. And in order to do that, we have to apply structure to it. We can't just put all our code in just one method. This we know. But I also think that structuring this code is our primary skill. This is what we have to be good at. And for me at least, this is where the object-oriented paradigm helps me. Because object orientation helps me group code into small, understandable units. It's not just one big method, it's small, understandable units. And this makes code easier to find, to understand, to add, to change, to fix, and reuse. And in addition, it also makes it easier to configure behavior. And here again we see the easier word. It has to be easy. Writing code should be easy, although it's a very complex task. So then the question is how to create these small understandable units. Because I think that these small understandable units are the key to structuring our code and to succeed in software development. In order to answer that, I'm going to talk a little bit about object design. I'm rather going to give a little example. I've drawn an object graph here, a small one, and it looks good. When I develop software, when I write code, I like to put myself in the perspective of the object I'm working with. So I like to say, when I'm working with B, I like to say, this is me. This is from where I see the world. And these are my dependencies. This is someone depending on me. And you see a faint E there? That's just someone else. Now the question is, how do I become, as B, how do I become a small, understandable unit? And the answer to this is it's really quite simple. Because the less I do, and the less I have to understand about my collaborators, the more understandable I am. So the less I do, the less I depend on others, the more understandable I am. the smaller and more understandable I become. And that sounds really easy. It's just do almost nothing. But it's very important. Okay, so let's look at this. Let's look at the less I do part first. In order to do as little as possible, I have to focus on just one concern, just one little piece of the problem domain. I'll come back to that. And the less I know about A, which is depending on me, it's important that you offer as little help as possible. You have to be very selfish when you develop and when you sit inside this object and say, I'm not going to help you very much. But I'm not going to be that kind of a bastard. So the little help I give as simple as possible. Because I know I also depend on someone, and I want the help to be as simple as possible. Looking at our dependencies, it's very important that you use them to solve your problems. Or in this case, B should use it to solve B's problem. And B should never ever care about their problems. Again, with the selfishness. You should focus on what they offer you. And you should never ask how they offer it. And you should not even ask who they are. Know as little as possible about your collaborators. And then there's this little E here. There's only one thing to say about him. And that's, we don't never want to know anything about E. We do not depend on E. What it all boils down to is my first and most fundamental and important guideline, which is separate your concerns. For me, in my style of programming, this is one of the fundamental rules. You have to separate your concerns in order to get structure. So for me, this is a guideline I have in the back of my head every day, every hour, every minute, all the time when I write code. For every line of code I write, I'm thinking, separate your concerns. Okay, so again, everybody has probably heard about separation of concerns, so it won't do just to say that. So what is a concern? It might be vague. I'm thinking, when I'm modeling and talk about concepts that I represent as objects, these concepts are concerns. And Robert Martin, Uncle Bob, talks about single responsibility principle. That's exactly the same as concerns. When we hear about things that have high cohesion, high cohesive units are probably containing just one concern. So these are all the same thing, really. And we should also know that a concern should be applied at all levels. It should be applied at the module level, and even further up, and at the class level, and at the method level. Different abstractions, but you should apply them at all levels. Okay. And then, how does this influence the code? How does this influence my code? To show that, I'm going to take an example. I seem to have become a bit of a masochist, really, because I really like going on the internet, picking up code samples and trying to make them better. I think that's very funny. and very interesting and very learning. I don't do it all the time, but I like to do it at times like this when I'm going to hold a presentation, because I also think it exemplifies things very good. So this time I've been on the Microsoft Web and I found an example on how to implement the producer-consumer pattern. I'm going to take this code and refactor it to show you what I mean about separation of concerns. First, just to explain the producer-consumer pattern. In the producer-consumer pattern, we have producers, we have one queue, and we have consumers. These are threaded because the producers and consumers are not concerned about what the other party is doing. The producer is just producing as fast as possible, and the consumer is just consuming as fast as possible. So these are threaded, asynchronous events. In the example code base, there are mainly 4 classes. There are the producer, the consumer, the sync events, and the main class. What I did when I did this code base and refactored it, I did of course refactor all these classes. But in order to save some time, I'm just going to look at the producer in this example. Okay, so what I do then is I'm going to start with another guideline. And that guideline is always find the object's primary concern and name it accordingly. So this is what I'm going to do with the producer. What I found with the producer, I think the producer is a coordinator that coordinates between the actual producers, which can be a lot, and the queue, which is the heart of the producer-consumer pattern. And then I came up with this description. It's supposed to make sure products are added to the queue according to the given configuration of the producer-consumer pattern. I'll come back to what this configuration thing is. And what I also saw was that it shouldn't be named producer. There are a lot of producers. This is a producer coordinator, so I renamed it in order to focus on the primary concern. On the next guideline, what I have to do next is to delegate all non-essential concerns. I'm just going to care about one concern, and that is to coordinate the producers with the queue. All other concerns, I'm going to take out. This is what the code almost looked like originally. I had to do it a little bit prettier. So this is almost what the code looked like. Do you see it? Everybody sees the code? Great. Okay, so what we're doing here is just basically we're running threads. We have one method doing a while and a lock and a while and something, and when you look at it, you probably don't really understand that much about this. And I didn't either. I had to work with this code a lot to understand what was going on here. Okay, I'll come back to that. I'm going to show that focusing on concerns enables reuse. I'm going to show it with this code base. If you start here, I just defined that creating items for the queue is not my concern. I'm supposed to coordinate this. I'm not supposed to create it. What this line of code does is creating it. So that's what I call a non-essential concern. So what I'm going to do, I'm going to delegate that concern. What I'm doing here is I'm taking in a function. I could have taken in an interface instead, but hell, I thought it was simpler to take in a function. So someone else is sending in a function pointer to me, which I don't know anything about. And I just execute that function every time I want a new item. So now I'm not responsible for creating the items anymore. I'm just responsible for adding them to the queue. Now, what I just did was focusing on separating my concerns, but what I just did also, as a bonus, was to get a class that can take in anything that produces integers, any integers, not just a random number between 0 and 99, which was the case just before. So now this is getting a bit more general. And if I think a little bit about reuse, I can do it like this, and that's just as simple. I use generics. And now this class, just because I focused on delegating my non-essential concerns, now this class can be used for anything. And now, suddenly, these 4 classes can be used as a general producer-consumer pattern framework. Just because I focused on this is not my problem. This is someone else's problem. So here you see the reuse without even really thinking about it. Okay. Next, I'm going to show that I think that focusing on concerns helps encapsulation. And encapsulation is also one of those terms. But for me, it really means simplifying access to some functionality. I'm going to show you what I mean about that. Again, if you look at this line of code, I bet you have no idea what's happening here. You might have some idea. If you're working with threads, and if you're working with threads on a daily basis, you know probably approximately what's happening here. I do not program threads every day, so I had quite a hard time understanding what this was about. So I had to debug, I had to read the code, I had to look at output in order to understand what this was. But finally, I understood it. And code shouldn't be like this. It's not easy if I have to sit and debug for 1 hour to understand what the code does. Code shouldn't be like this. But this very, very strange sentence is really saying just one thing. It's telling me when to terminate. So instead of having to talk to sync events, getting some object out of it, calling some strange method, I want to focus on what it can help me with and not how I can solve it myself. So I want it to look like this. This is not my concern to figure out. I just want to know when I should terminate. This is not my concern. It's a sync event object that should have that concern. Okay. So what I think we see here is that encapsulating is something you do to simplify use. Okay, I won't go into details with the rest of the things here. I'm just going to nail the rest of the concerns here a little bit faster. If you look at this one, again, if you work with threading on a daily basis, you know what this is. And you might think I'm a bit stupid for not really knowing why you should use the sync root on the collection. I know that you should do it, but I really, honestly don't know why. So I had to sit and figure out, why do I have to lock on the sync root of this queue, and why couldn't I just lock on? This is not my concern. Again, I have to solve the how to do this. I just want to focus on the what. So what I do here is that I tell the queue, you should lock this. I don't know how to lock this. My concern is that I want an atomic operation. And that's the while sequence you see nested into that lock method call. That's my concern. I want that as an atomic operation, and I don't want to know how I do that. So I'm going to send that concern to the queue. Okay. Again, I had to sit and wonder why this happened. I had to read. It came with, the code base came in an article. I had to read the article many times to understand this whole code base. Did I mention code shouldn't be like this? What it does, it just messages that something has been added to the queue. That's not my concern. I don't want to know that I have to message someone that I just added something to the queue. I just want to add it to the queue. That's my concern. So what I'm going to do is I'm going to say, queue, you have to fix this. I don't care about it. It's your problem. Okay. And now it's pretty much one concern at the class level. Now I think we're down to one concern with this producer coordinator. But I'm going to do just a little bit more. I'm going to show you that this focusing on concerns also will give you, I think we already have cleaner code, but I'm going to make it just a little bit more clean here. Because I'm going to focus on the method level, the function level. Because again, we have this little piece of code, which again, I had to debug and read to understand what really did. The fact that it says 20 gave me a clue, but I had a hard time getting sure what this was about. Because debugging multi-threaded applications isn't really that easy. But at last I found out that this little piece of code is just saying, keep 20 items in the queue at all times. And when I at last found out that that was what this meant, I didn't really want to lose that knowledge. And I also wanted to tell everybody else about, I found out this. So what I did then was I extracted the method. Because what I thought was that the thread run method shouldn't really be concerned about how you keep these 20 items in the queue. It should be concerned about that it should be kept 20 items in the queue. So I created another method that's one concern was to actually keep the 20 items in the queue. Okay, so what a guideline I draw from this is good method names speak clearer than code. If you don't understand code, you should probably either just rewrite the whole thing, or often extracting methods like this helps you understand the code better. And the other thing is a method should do one thing only, which also means a method should have only one concern. Okay, let's look at the final result. The scope was to create smaller, more understandable units. And we defined that this producer coordinator's responsibility, concern, was making sure products are added to the queue according to the given configuration of the producer consumer pattern. Now let's look at the code. What does it do? It's adding items. Yeah, that's my concern. It's terminating when told. Yeah, that's configuration. And it's keeping 20 items in the queue, and that's configuration. Now it does nothing else. This, in my mind, is a class with one concern. Now you're probably thinking that what I did, focusing on just this one class, was to take all the garbage and putting it somewhere else. So you're now probably just seeing that I have this one nice class and I have a mess all around me. But quite the opposite, actually. And this is very interesting. Because when you delegate concerns this way, you're often enhancing your collaborators. If we go look at the sync events class, we had the sync events object that did all kind of strange things. And what I did was say, no, this is not my problem. No, this is not my problem. Because what we had to do with the sync events object was that we had to get out all the strange objects and we had to call some methods on it. We had to solve all the problems ourselves. And we don't want to do that. So when refactoring the producer coordinator class, what we actually got here was we took away all these properties which just offered information and making us have to resolve all the problems. And it turned out like this. Now what it does, it offers help. The sync events has to figure out how to understand when you should terminate, how you should terminate, how to message when an item is added. Now this is encapsulation, because now sync events is offering simple use, which it did not do previously, because it just offered properties, and you had to get the properties and figuring out everything yourself. Now the sync events has its concerns, and the producer coordinators has its concerns. And this is, what I draw from this is a guideline I like to call Ask for Help, Not Information. I read that in a book many years ago by Alan Holub, which isn't a big name in the .NET community, I think, but it was a great book. You probably heard Tell, Don't Ask, which is exactly the same thing. The point is that as a producer coordinator, I should ask for help. I should not ask for information and solve all the problems myself. And all this, I think you get almost free just by thinking about concerns. Separate your concerns. Okay, I'm going to talk about another thing in development, which we do all the time and probably don't think that much about. It's object construction. It's writing new. I strongly believe that objects should be in a consistent state at all times. You can't just create a partial object and send it into the world and hoping it's going to work, because that's going to throw a lot of exceptions and it's going to cause a lot of bugs. Objects should be in a consistent state at all times, because you should make sure all your dependencies are set when construction is finished. Why should you do that? It lies in the name, really. Dependencies is something you depend upon. It's something you require to work properly. And in order to be consistent at all times, you have to make sure these dependencies are set when you're sent into the world. So you have to make sure they are present when the depending object is present. The guideline for this, and this works very well for me, is when the constructor is finished, construction is finished. I think that's why it's called the constructor. Construction should be finished when you finished the constructor. And then, of course, I think that constructing objects is a separate concern. Let's look at an example. I've got a class here, or rather an object, which helps with adding discount to an insurance. Example I just took from the top of my head. It's not from any real code base. But then again, I see a lot of this kind of code. You should add a discount. You get in the discount, and you get in an ID for an insurance object. What we do here is that we call the repository to ask to get the insurance that is associated with this idea. And then we add the discount. Now the question is, where does this repository come from? Well, when you're constructing object, you could just write new. You could just do like this. Okay, let's try. New insurance repository. Let's see, what parameters does it take? Okay, it takes a unit of work class. Ah, great, that's easy to create. We can do it like this. And then we just add it to the method. And then the code looks like this. What did we just do here? We're really doing something which I said you shouldn't know anything about. You should never know anything about someone else's dependencies. And we know that here. And I do not know, when I sit inside of this object, I do not know and I do not want to know anything about this dependency. And anyone that has been working with repositories and unit of works knows that this won't work. You can't just write new unit of work, because I'm guessing there are someone that's sharing that object. So this doesn't really work. You have added a concern to your code, so you have to write more code, you have to concern yourself about more. And you also probably added an error here. So my guideline is, of course, to delegate all non-trivial object construction. I'm saying non-trivial because I write new around in my code too. But I write new when there are simple objects I'm creating. You shouldn't be all fundamental about this, but what I see in the code bases that I see is that we write new way too often, way too much. We should, every time we sit down and start writing new, you should think, should I write new here, or is this my concern, or is it someone else's? And I think often it's someone else's concern. Now, what this means, if you want to delegate it, I think you should do it like this. Because what I said earlier was that when the constructor is finished, construction should be finished. What I'm doing here is I'm saying that creating the repository is not my concern. So I have to delegate it. And I also said that when the constructor is finished, the construction should be finished. So I have to give someone else the responsibility to create it and then take it in to the constructor. So simply, when you depend on an object, request it through the constructor. Okay, similar to what I was talking about now is that assembling the system is a separate concern. And what do I mean about assembling the system? An object-oriented system looks quite like this, somehow. A system is a web of objects. And probably at startup, you make a lot of decisions as to which objects should depend on which. And that is the part when you're assembling the system. And probably, at least if you're not using an IOC framework or something, probably you're not thinking, at least I'm not always thinking that much about when I'm assembling the system. But I think it's important to see that this assembling of the system is also a separate concern. I'm going to take a couple of examples here. I'm going to first start with an example showing you how I can configure behavior this way. Now let's say, if you go back to this, we have this insurance repository. And let's say about 50 objects are depending on this insurance repository object, on this one single insurance repository object. And all these 50 objects is writing this insurance equals repository get insurance ID. Now the problem, you will hopefully not perhaps probably, you will get a problem when someone says, uh-oh, we need caching. A lot of times it's not a smart thing to implement caching, but sometimes you have to do it. I've done it. I don't know if it was smart to do it there, but well, I did it. Now then the question is, where caching is a concern, where do I implement this concern? Well, you can implement caching in all these objects that depend on it. And I think we all know that that's a stupid way to do it, because that's a major job and that's a lot of duplication. Most of us is probably saying the caching should be implemented in the repository because that's the same concern. I've seen that done with quite simple caching, and I think on the project we disagreed on this, but I didn't really like that code because I thought the code got messy. Because I thought that in the insurance repository we got several concerns and it got more messy than it had to be. So what you could do, you could create another class which one single concern is to cache insurance objects. Okay, let me show you how this would work really fast. Okay, someone calls get an insurance. What I do then in the insurance caching object, I check if I already have cached that insurance. If I have, I return it. If I haven't, I ask the insurance repository to get it, and then I cache it. So the next time someone asks, I just return the cached value. Now, if you're lucky, this repository, this insurance repository, implements an interface, and all these 50 objects that depend on it takes in the interface and not the concrete repository. Because then what you could do, and this is really, I think this is elegant. This is so object-oriented. But be aware, it's not so elegant that you should do it all the time, because there's an overhead with doing this. But sometimes this works very well. Because what I'm doing here is that these 50 objects that uses the insurance repository, or rather an interface that it believes to be the insurance repository, you can now, when you're setting up the system, you can now send them the insurance caching instead. And then you send the insurance repository to the caching. And then they work just as before, and they don't know anything. The insurance repository object knows nothing about the caching. All the 50 dependent objects knows nothing about the caching. There's only one object here that knows about caching. And that's the insurance caching object. So that's its concern and nobody else's. And the code looks much cleaner when I do it this way. But this won't work if the depending objects themselves decides who is going to play the role of the insurance repository. If they write new insurance repository in all the 50 objects, then you can't do it this simple. Then you have to fix and change, and then that's going to be a major job anyway. So this is about setting up the system. So I think that depending on interfaces enables configuring the system. And I'm not saying that you should use interfaces all the time. I know this is a big discussion, but I think you should use it when it feels logical to use it. When there's something non-trivial going on, you should use interfaces. Okay, the code will look something like this. If the class is called discounter, then this is the constructor. It takes in the interface insurance repository, not a very pretty name. In the application setup, or at least somewhere outside the discounter class. We wrote it like this before. We instantiated the insurance repository and sent that into the discounter. Now all we have to do when we have applied caching is we can do it like this. We just write new cache repository instead of insurance repository and send it into the discounter. This is, if you're not using an IOC framework, which I won't go into details with here, this is also going to be a little bit more code. But with an IOC framework, this would be changing just one place in the code and all the 50 objects would just get the cache repository. But I won't go into details there now. Okay, another example when it comes to setting up the system is that objects might share other objects, and they should probably do it unknowingly. If you remember the producer coordinator, it took in two objects. It took in three objects, but two of them was a queue and the sync events. And the reason for this is basically that both the producer coordinator and the consumer, or I should probably call it the consumer coordinator, is dependent on the same object that the queue is. Not the same class, but the same object. It wouldn't help much if the producers were putting something into one queue and the consumers were taking something out or everything out of another queue. They have to talk to the same queue. So there we have two objects that depend on the same third object. And in this case, if you shouldn't delegate the concern of constructing the queue and setting these objects together, if you shouldn't do that, then either the producer coordinator or the consumer would have to instantiate the other producer coordinator or consumer and send in the queue that it also instantiated. And then the code would look pretty messy and you would have a lot of concerns all over the place. Okay. Doesn't really matter. So deciding what object you depend upon is often a separate concern. So taking things in through the constructor is often a very smart thing to do, I think. But not always. Don't overdo it. Don't over-engineer it. But do it a bit more than the industry is doing today, I think. Okay. I'm going to talk about something else again. Aslak Hellesøy and Dan North, I think they coined the phrase least paranoia and least surprise when they were talking about their good citizen pattern. I really like this phrase. This is how I want to develop software. This is how I want to write code. Least paranoia and least surprise. Because using existing code should be a joy and not a minefield. I shouldn't have to be paranoid and I shouldn't have to be surprised. And one thing that we do today that makes my life not as fun as it should have been is that we use a lot of nulls. And I think nulls are to code what spikes are to tires. And I really mean that. I hate nulls. Okay, let's have an example here. If you go back to the add discount method, which takes in the discount and the insurance ID and talks to the repository, and then it asks the repository to get the insurance object, and then we take the insurance object and we add the discount object to the insurance object. We all have seen this. This is a null reference exception. We get this. I feel like I'm getting it all the time. My code is probably bad. Now, I try to avoid this because nulls cause runtime exceptions, and this makes my life, and probably your lives too, not as good as it should have been. I want to avoid this. Now, what we usually do, if you look at this code and we get an exception there, what we usually do, I think, is that we write, okay, great, fine. We say if insurance equals null, we just return. And I've even done that myself, and I'm not proud of it. And you've probably done it too. Because then the question is, what did I just do there exactly? How smart was that? What I did here was that I added another concern. This is a totally different concern than what I was doing, because I was adding discount to an insurance. Now my problem is, I have to resolve, why did I receive null? I was just adding discount. And what should I do if I receive this null? I think that what the repository object is doing is that it's handling exceptions in a very bad way. I think it has gotten an invalid insurance ID, and it says, no, I can't handle this. It's your problem. But that shouldn't be my problem. It should be its problem. So I don't want to check for nulls all over the code. Because what am I supposed to do if he can't do what I'm asking him to do? What am I supposed to do? I was just adding discount. This is not my problem. So don't do it this way. Don't use null as exception handling. And don't use nulls all that much altogether, because I think handling nulls often introduces other very misplaced concerns that makes your code a lot harder to read and understand, and it's probably going to be more bugs in there too. So my diplomatic advice about this is at least think before you use nulls. And I'm going to give you a rule of thumb here too, because when you're writing code, if you get to a point where you think, this has to be the place I'm actually supposed to use null, I would strongly advise you to set aside half an hour to try to figure out how you can solve this problem without using nulls. If that half an hour has passed and you still believe that using null is a good idea, it might be. It's probably not, but it might be. Then you might do it. But think for at least half an hour before you use nulls. Okay, I'm going to talk a little bit about readable code. I'm not going to talk that much about it. There's lots of practices on readable code. What I think it all boils down to is really a single advice. But what we should think about is that we spend way more time reading code than writing it. Because the second you've written a line of code, which takes you, say, 5 seconds, you read it over and over and over and over. And by the time you're just done with the method that line of code is a part of, you have read that line of code a lot of times. So I think the general guideline, which really boils down to, which really encapsulates all the practices, is if you think a little bit about that someone else is going to read your code and make life easier for that someone. If you think about that when you're writing code, when you're putting variable names, that is one letter, think about someone's going to read that one letter and wonder, what is this? And most of the time, that someone is you. So in order, if just out of pure selfishness, think about how you will understand the code when you have to go back into it. Okay, another thing about understandable, readable code is You should not have to enter a function to understand what it's doing. There's probably no men in this audience that would enter this door in order to understand what's going on in there. Because we understand that. And that's how methods should be like too. It should be really easy to understand what a method does just by looking at it. You shouldn't have to go into the method, because if you have to go into every method, it's going to be a cognitive overload. You're not just in this little understandable piece of code. This little concern, you have to understand this and that and that and that. And that's going to cost a lot of time and agony. So my guideline on this one is a method should have a clear name describing what it does, and it should do just what it says it does and nothing else. Okay, I'm going to sum up with testing. I call it automated testing, unit testing. I'm not going to talk that much about it because I think there's a lot of other people that's going to talk about it at the conference. So I won't go into details, but what I'm going to say about it, I think automated testing is an integrated part of development. We have to face that. At least I've faced that. Simply because, among other things, you have to make sure your code works. And automated testing is by far the best way I know to make sure that my code works. There might be others, and I'm pretty sure we'll find out something in the future, but for now, automated testing is for me the by far best way of making sure my code works. And you have to do that. I think we all know that. And I also like to say that testing is coding. Apply the same style of programming when you write tests as when you write code. There's no second, don't slap around there. Just do it, write it at least as good as your production code. And of course, you test one thing at a time, or should we call it one concern at a time? You do it just the way you write your ordinary code. So you write this little test. You're going to test one concern, and we all know that one concern is coupled to another concern and yet another concern, and there's always a database down there. But my point is that when I follow this style of programming, it makes testing very easy. Because this style of programming lets me isolate this one single concern. Because I have only have these small single concerns. And they're easy to test because they're encapsulated. There's one concern here, there's one concern there. And when we talked about this concern about constructing, you also get the advantage here because you will have dependencies. But when I, in my test, can say, okay, normally you're dependent on this object that talks to the database. I don't want to talk to the database when I'm going to test this little concern. So what I'm going to do is I'm going to fake all those dependencies. And it's going to be easy for me because that's the way I write code. So this is, a lot of people talk about writing tests first because that makes you write this kind of code. And that's right. But looking at it the other way, no matter if you write the test first or last or whenever, this style of programming gives you that kind of coding style anyway. So this is, for me, this is free. It's easy to test. Okay, I've got half a minute left, I see. So I'm going to sum it up. And it's not that difficult, really. It's just about creating small, understandable units, one concern at a time. And think about that all the time. For every line of code you write, whose concern is this? Whose concern is this? Whose concern is this? Okay, thank you.